I'm not going to talk for any longer. I'm going to invite Logg to the stage, who is the director of the Digital Twin City Centre and a professor of computational mathematics here at Chalmers, to welcome you. Anders.
So welcome everyone to DTCC. So we are a research center here at Chalmers. Chalmers has 2 campuses. This is one of them, and I'm happy to see so many of you here today. I know many of you were here already yesterday for our introductory workshops. We also had the local Digital Twins Forum meeting at Chalmers, and we had a great meeting and dinner with our International Advisory Board. So a first great day, and I'm looking forward to another great day today for our main event, which is this conference. So before we begin with the main events, the keynotes, I will say a few words about our center, so you know where we come from. We are an interdisciplinary research center here at Chalmers devoted to the exploration and application of digital twins. We are around 35 partners now in the center. We are a funded center by Vinnova, a so-called competence center. We are hosted by Chalmers. We are hosted by something called the ICT Area of Advance, who have also been sponsoring this conference. We are hosted by the Department of Architecture and Civil Engineering at Chalmers. But we are an interdisciplinary center with researchers from mathematics, computer science, and architecture and engineering. So many different disciplines needing to come together to create a research center like this. We're grateful for our many partners in the center. You can see all of them here, and I think most of them or all of them are even represented at this conference today. There will be some great exhibitions outside in the break later, where some of our partners will show what they are doing with digital twins and what we are doing at the center together with our partners. So a little summary of some achievements so far in the center. We've been running for now 4 years, close to 4 years. And since the start in 2020, we've added around 10 new partners, or actually 10 new partners to the center, 39 new projects funded. So we have been very successful in using the center as a platform for applying for new grants, adding funding to the center, scaling up to be able to do more projects with the center as a platform. 67 publications, 69 talks, 15 public events, including this one, a large number of education activities and student projects. So been quite busy so far. So before we begin with the conference, I want to say what I think is, or what we think is, a digital twin. So there are many definitions, and this is our way to try to summarize what we mean by a digital twin. So I would say that it is a model, and all of us have different understanding of what it means to be a model. For me, with a background in mathematics, it's very clear what a model is. It's a model of a physical system like a city that mirrors the physical city in real time and enables 2 things or 3 things: analysis, prediction, and control. So if you have those 3, then you have a digital twin. If you don't have those 3, you might have something that you might call a digital twin, but it's sort of not really living up to the full extent. So this also implies there is a 2-way coupling between the physical twin and the digital twin, because you have this control and analysis. You need to be able to couple these in real time. So why would you want to build digital twins? What are they for? Well, the twin answers 2 basic fundamental questions. So one is what is? So that's analysis. You can analyze the city as it is right now based on data, and that enables operation and maintenance. The other question that you can answer is what may be. So that's prediction. So that you need to do some kind of mathematical modeling and simulation, or alternatively machine learning based on data, to be able to predict things, to enable planning and development. What are then the main challenges, in my view? So the main challenges are, I mean, you can say there are technical challenges, of course. If you want to build a model of a complex system like a city, that model necessarily becomes complex, and it's very challenging to solve that big coupled multiphysics problem that you have. Of course, you have technical challenges when it comes to complexity, performance, and quality. But some of the main sort of unexpected, or maybe they are expected, challenges are all related to data. So data ownership, who has the data? Can I use it? Can I get it? So we have been struggling with this, and that's different in different countries. We have a special situation here in Sweden that we can discuss more later. How do we actually get the data? Can we get it? If we get it, can we share it? Can we reuse the data and share it with our partners? Quality of data, that's something that comes up quite a lot. So if you look at this model here, this mesh of a city, to someone that's a great model. That's high quality data. To someone else, it's lacking detail. And if you ask someone who wants to do CFD on this mesh or another mesh on top of this, they might say that, well, it looks good, but I mean, I really want the mesh metrics to be like this. You might have very particular needs. So different disciplines, they have very different views on what it means to have high quality data. And that's something we need to bridge, because we are working together in a big group and everyone wants to work on the same city, but everyone has very different requirements on what the model should look like. And then the third one here, data sustainability across time. So if you create a digital city model, a digital twin, it shouldn't be, we discussed this yesterday in the Digital Twin Forum, it shouldn't be a project, it should be a process. So we emphasize the way that we can build these models based on raw data, and we can build them again and again and again. So setting up those processes, they need to be maintained and alive. So it's not that you create a twin, then you have that for the rest of your life. It might become obsolete just a few weeks later. So it's a process rather than a project to build twins. Which is why we might instead want to talk about digital twinning as a process rather than having a digital twin. So a few words now before I leave is to say a few words about what I think the future is. So the future is, I mean, something we realized is that digital twinning, it's not a magic one technology that solves all problems. I mean, it's a vision, it's a very useful vision, but you still have to do all the hard work. All the technology that you have developed, that people have been working on for many, many years, they need to come into play, and you need to be able to take things even further, because there are more challenges when you want to simulate something in the context of digital twin. It needs to be fast, you need to be able to answer questions, it needs to be interactive, so it puts new challenges on the modeling and the simulation. I think the vision is the same now as it was in 2019 when we started. Maybe it was a little bit blurry than the vision, but it has sort of started to clear up. We have the same vision of building, of digital twinning as we had in 2019. The keys, I think, are federation, so that's about interconnection and interoperation between models, between systems of systems and digital twins. Openness, open data, and open source. Doesn't mean that we cannot connect perhaps to proprietary software and things that are not, we're not building a monolithic digital twin open source, but the open source comes in when you talk about the connectedness and the open data formats that you use in order to connect these systems together. Reusability, so we need to build things that we can automate, that we can modularize, so people can pick and choose and reuse components of the things that we are building. And of course, integration, so leveraging existing technologies, great systems and tools that people have been using, great formats that people have been inventing over the years. We need to be able to connect those and build on those to build something better. So thank you very much. I will now leave the stage for our first keynote, I think.
Thank you, Anders. Our first keynote is Professor Jantin